Welcome once again to this YouTube channel. The previous videos on organic chemistry, we have introduced what organic chemistry is about, and we have seen what a structural isomers is about as well. So the same principle that applies to deriving structural isomers of the alkanes applies to that of the alkenes. So if you understand what we did for the alkanes, you can equally, rearrange the structure to get structural isomers of an alkane. Right. So in this particular part of this video, we would just look at some of the chemical reactions of the alkanes and that of the alkenes, and then we can talk about do some past papers, IGCSE chemistry past papers on this concept. First is to understand that when you talk about chemical properties, we also have what we call the physical properties. So the physical properties has to do with the melting points, the boiling points, okay, or the size of the alkanes. And you should understand that as the number of carbon atoms increases, the melting point equally increases. So as the number of atoms, as number of carbon atom increases, you expect that the melting point also melting point or the boiling point will equally increase. So that is how it works. We'll talk more about this when we go into crude oil. Look at fractional distillation of crude oil, the fractions gotten from crude oil. But that's just a concept I just want to point out as a physical property of the alkanes and the alkenes. As the number of carbon atoms is simply increasing, the size is increasing, and of course, the melting or boiling point would increase. All right, so that's just by the way. So the major focus on the reactions of the alkanes, which is more like the chemical properties of the alkanes, is to look at what are those reactions that they undergo. Okay, so the first reaction that we'll be looking at for the alkanes is number one. I'll call it a combustion. Combustion. All right, so alkanes undergo what we call combustion. And what do we mean? What do we mean by combustion? It means burning the alkanes in air, or we say burning the alkanes in oxygen. All right, so when you burn an alkane in oxygen, we simply call that a combustion reaction. All right, now there are two types of combustion reaction. There is the complete combustion, and we also have the incomplete combustion. All right, so you should be able to identify the difference between the complete combustion and the incomplete combustion. For the complete combustion, what it means is that there is excess supply of air, or we say excess supply of oxygen, excess supply of air. That is when you're burning the hydrocarbon, precisely the alkanes, in excess supply of oxygen or excess supply of air. We call that complete. And then it becomes an incomplete combustion when it is burned in limited supply of air, or you could say of oxygen, as you want to define it. All right, so that's the difference between the two categories of a combustion reaction. I just have to erase this. All right, so what there are other differences between the complete combustion and the incomplete combustion. It has to do with what kind of products that are going to be formed when it's a complete combustion and when it's an incomplete combustion. If it were a complete combustion, the two products would be carbon dioxide and water. Okay, and if it were incomplete, so these are the products, and if we have an incomplete combustion of an alkane, you're going to produce carbon monoxide and water. So you can see that there is a difference in the products formed for complete combustion of an alkane and for incomplete combustion of an alkane. Okay, so let's just do a couple of reactions showing all of this happens. All right, so we're going to have complete combustion. So we're going to just use the third member of the alkanes. Remember the general formula of the alkanes is CnH2n plus 2. Always remember this. And I want to generate a third member, which is propane. So we're going to have N equals to 3, so C3H8, basically. Okay, now we want to react it with excess supply of air in one of our reactions, and then we're going to react the same propane in limited to show incomplete. So we want to show both complete and incomplete combustion taking place in both cases. All right, so moving forward now, so what we're going to have is, we already said that the product of complete combustion is a CO2 plus gas carbon dioxide and water. And that of incomplete combustion is carbon monoxide uh, plus water. All right, so the next steps are to balance the equation. All right, to balance the equation. Remember that this is complete for complete, and this other one is for incomplete combustion. All right, so let's balance it up. We have 3 carbons on the left, so we should have 3 carbons on the right to balance the number of carbon atoms. There are 8 hydrogens on the left, so what do we do to make this 8? We put a 4 here, so it becomes 4 times 2, and equally 8 hydrogens on the right. All right, so there are just 2 oxygens on the left, but let's see how many oxygens on the right. We have 3 times 2, so there are 6 oxygens here, plus 4 here, so that's the total of 10 oxygens on the right. So to make 10 oxygens on the left, all we need to do is to put a 5 here, and that balances the complete combustion equation. So it's not just about writing the equations and identifying the products. You should also be able to, balance the equation. Okay, so we go to the next one, which is incomplete combustion. We have to balance this as well. So there are 3 carbons right here, so we need to put a 3 here, and then also 8 hydrogens. So we have to balance this up by using the 4 here, so it becomes 4 times 2. All right, and then we look at oxygen this time. So oxygen here, this is a 3 here, 3 oxygens here, plus 4 here. That's 7. Okay, 7 oxygens on the right, and then we have just 2. So sometimes we become very confused. Oh, what number do I need to multiply by 2 to get 7? So just save yourself that time. This is 3 plus 4, this is 7. So write the 7 right here, and then divide by the number you're trying to think of. So divide by 2. Okay, so that's how it works. All right, so the next thing is, you could balance equations this way, or you could simply try to eliminate the fractions. So I want to eliminate this. I want to make it just like the first reaction where we have complete combustion. That is, I want to make this a whole number and not a fraction. So what I need to do is to multiply everything by this denominator, the 2, so that the 2 would cancel out. So I'm just going to show it now. I'm going to multiply this by 2. So I'm going to have 2C3H8, okay, plus I'm going to multiply this by 2. So if I multiply this equation by 2, what it's going to look like is, it's going to be like 7 over 2 times 2O2. All right, so you don't get confused. I just write it the way it appears there. Okay, so let's write it this way. Of 2 times 7 over 2O2. This is what we have. All right. And then you multiply this by 2 as well. So we're going to have 6CO. And then you multiply this by 2, you're going to have 8H2O. All right. So from your knowledge of mathematics, this will cancel this. So this is 1 now, becomes 1. So 7 times 1 is 1. So what would the final equation look like by the time we do this? We want to check if it's going to be balanced. Okay, so it's going to be 2C3H8 plus, so 7 times 1, that's 7O2. And we're also going to have 6CO plus 8H2O. So let's check it. Let's check the equation if it is balanced. All right, 6 carbons on the left, 6 carbons on the right. That's good. 16 hydrogens on the left, 16 hydrogens on the right, 14 oxygens on the left. Let's see how many oxygens are on the right. 6 plus 8, 14. So this is one way to balance equations. You could use fractions, and then you could clear out the fractions by multiplying by the denominator. Okay, so that is how it works for complete and incomplete. So you can see that the equations are quite different for complete and incomplete. So this summarize the incomplete combustion of the alkanes. And you see that this is a toxic gas. Okay, it's a toxic gas from your knowledge of chemistry environment. This is a toxic gas, and this is a greenhouse gas. Okay, so we can see that the products are different in terms of carbon dioxide and carbon monoxide. All right, so that's the first reaction that alkanes usually undergo. So we're going to go to a second kind of reactions that alkanes undergo, and I'll call that reaction substitution. Substitution reaction. All right. So basically, in substitution reaction, just like for those of you who watch football, this term substitution is usually used in a football match. Okay, when you need to remove a particular player to replace that player with another player. So that is how it works also in alkanes. They undergo substitution reaction. That is, a group is replaced, a group replaces another group. So a group replaces another group, replaces another group. So
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, what is in 2026, what is 2027. We're currently ongoing, and this is actually a good time for you to actually explore and then get it tailored to your own needs. So trust me, you don't want to miss out.
Example, let's just look at an example of a substitution reaction. Okay, so for substitution reaction, majorly two products are formed. So another feature of a substitution reaction is that you're going to have two products, okay, being formed. All right, so which is very important, two products are formed. Now, an example of a substitution reaction of an alkane is what we call halogenation. So it is halogenation. Halogenation is an example of a substitution reaction of uh, alkanes. All right, and in the case of halogenation, just like the name implies, halogens are simply you're introducing a halide group. So the halide group, you know what the halide group is. So we're talking about the group 7. All right, so you're introducing the halide group, any of the halide groups, to replace hydrogen. All right, so the halide group is the group that is incoming, and the group that is being removed is the hydrogen group. Now, in the case of halogenation of the alkanes precisely, of course, you're looking at halides such as chlorine, fluorine, or and all other halides that you might think about. Now, the halogenation reaction requires that you use sunlight. Sunlight is a requirement for the halogenation reaction. Either you use sunlight or you use ultraviolet light. Very important. This is a very important requirement for a halogenation reaction of the alkanes. Now, why do you need sunlight or ultraviolet light? Okay, you need sunlight or ultraviolet light because the sunlight or ultraviolet light would supply the ultraviolet light or sunlight supply activation energy. So the lights that you're introducing will supply the activation energy needed for the reaction. And of course, you know what activation energy means, okay? The minimum amount of energy needed for a reaction to occur. So for this reaction to occur, there is a need for an activation energy. And that activation energy is supplied when you use sunlight or ultraviolet light. All right. And then whenever a reaction requires sunlight, okay, for the reaction to occur, that reaction is simply called photochemical. Okay, so a reaction that requires sunlight. So requires sunlight or ultraviolet, requires light. Okay, so any reaction that requires light or requires sunlight or UV light is termed a photochemical reaction. And we already said that this light, what it simply does is that it supplies the activation energy needed for that reaction to occur. All right, so an example of a photochemical reaction is also when you talk about photosynthesis. Remember, your photosynthesis is also a photochemical reaction because it needs light. It needs light. Sunlight is needed, including chlorophyll, but sunlight is equally needed for photosynthesis to occur. All right, so now that we've introduced what halogenation is, so you're introducing an halide group, substituting out one of the hydrogens, and then it requires sunlight or ultraviolet light. And the function of the sunlight or ultraviolet light is supply activation energy for the reaction. And we also said that any reaction that requires sunlight or light generally is called a photochemical reaction. Okay, so let's look at the typical alkane now undergoing photochemical reaction. All right, so we're going to pick the first member of the alkane this time, which is methane. So I'm just going to draw methane. So this is methane. Methane is CH4. All right, so this is methane. All right, and this time we want to introduce let's say we want to introduce chlorine. Remember, this is the we're introducing the halogen now, which is the diatomic chlorine, and we already said that UV light is needed for this reaction. So it's a photochemical reaction. So I'm just going to open up the chlorine. So I'm going to open up this chlorine, and it's going to look like this. So what substitution simply means is that, I'm just going to change the color of my marker this time. What substitution simply means is that one of the hydrogens needs to come off, okay, and that hydrogen needs to be replaced by chlorine. All right, so it's just like I want to substitute you for this. So you come off, so that chlorine will take the place of the hydrogen, and then the hydrogen too, in turn, will take the place of the chlorine. Okay, so that's what substitution is. Hydrogen come off, let chlorine take your position, and then hydrogen should go ahead and take the sitting position of the chlorine initially. So that means there are two products that will be formed, like we earlier said. So if I'm to draw the end product of this reaction,
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2024, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
okay, it's going to look like this now. C H H H, and I'm going to just to show you clearly. I'm just going to use a different marker to show you the chlorine that is coming now. All right, so plus now. Okay, so and then we're going to have plus HCl. So this is what happens in a substitution reaction. You can see that one of the chlorine has been substituted into the methane group, all right, and then the hydrogen removed has taken the place of the chlorine. And this is what we mean by halogenation, or we say substitution. Two products are formed, like we said. So this product is now called chloromethane. Chloromethane. And of course, you know what this is already. This is a hydrogen chloride. All right. So this is what happens in substitution. So what we'll do is we'll continue to substitute. Okay, maybe we want to keep up the substitution. So I will just continue the substitution to show you how the substitution continues from there. So we could have HCl, sorry, pick it up from where the products that we formed. So we could continue to substitute chlorine into it. So if the first substitution is a mono substitution, we can also have a di substitution like that. And so add chlorine again. All right. Remember the requirement is still the ultraviolet light playing a role. All right. And then in this case, just like we did again, this time, I'll just change the color again. But this time the chlorine now goes to a different, tries to abstract this, okay? So the swap position, that's substitution, in this case. So our product now is going to be like H, C, so Cl, H, Cl, and then we'll still have HCl again. All right, so this is now called dichloromethane. Okay, so you could keep on substituting like that. So you could pick the dichloromethane, substitute chlorine in again, it becomes trichloromethane. Substitute again into trichloromethane, it becomes tetrachloromethane. So that's how it goes for the substitution reaction, or we say halogenation reaction of the alkanes. All right, so that is how it works, and I believe you understand what has been done. So two products has to be formed, and then you can see that the chlorine goes in one after the other. And that's due to the nature of the compound we are dealing with. Okay, it's saturated, right? And remember what we said about saturated, they are generally unreactive, so it takes a while for each of the chlorines to go in. All right, so that's reaction number two of the alkanes. All right, so remember all of the conditions we mentioned, that it has to be it takes place in the presence of light, and we also look at the function that the light plays in that reaction. So we just go straight to reaction number three for the alkanes. So reaction three is called cracking. Cracking. Okay, so and what cracking simply means is breakdown, or the breaking down of a large alkane. So we breaking down of a large alkane, breaking down of a large alkane to produce smaller useful hydrocarbons or products, as the case may be. All right, so using a catalyst and heat, okay, or we could say using a high temperature. So whenever we want to undergo cracking, we introduce a catalyst, okay, we introduce heat, all right, we also introduce some pressure in some cases, all right, just to break down the larger alkane. At the end of breaking down the larger alkanes, you want to produce smaller useful hydrocarbons or other products that you could use for other functions as you might want to use them for. All right, so in cracking, let's see, if you have a larger alkane, sometimes when you crack, okay, when you crack this, you'd have a smaller alkane plus a smaller alkene. All right, so we have cases like this where you have smaller alkanes and smaller alkenes, but all of this depends on how well you can balance the reaction. Okay, it's this type of cracking also follows the normal the normal principle of balancing chemical equations, where the total number of carbons and hydrogens on the left should be equal to the total number of carbons and hydrogens on the right. All right, so or sometimes you could also crack a larger alkane, and then you're going to have smaller alkene. So you could have a smaller alkene 1 plus another smaller alkene 2, and then you're also going to produce hydrogen. Okay, so this second method of cracking produces hydrogen that could be used in the Haber process. So this second method could be used to supply hydrogen for the Haber process. So it all depends on what the question is like. So when we go into past questions, you see the template. The template tells you what you need to do, but the principle remains that the number of carbon atoms and hydrogens on the left should be equal to the total number of carbon and hydrogens on the right. So that's the principle behind cracking. So I'll just give a quick example of cracking. Let's say I want to crack, let's pick a large alkane such as, let's say pentane. Oh, sorry, let's say decane. I want to crack decane, and remember the general formula of alkanes is CnH2n plus 2. So decane is N equals to 10. So that's C10H22. So I want to crack this. So I could crack to produce the first template. I could crack to produce a smaller alkane like C4. Okay, I could produce a smaller alkane like C4H10. Now, the moment I produce C4H10, the next thing is to produce an alkene that will sum up to give this C10H22. So it could be C6, all right, and it has to be H12. All right, so this is what I'm talking about. 4 plus 6 has to give me 10, and then 10 plus 12 needs to be 22. Remember that this is now an alkane, this is a smaller alkane, and this is smaller alkene. All right, so I could use this way, I could crack this way. I could also crack with the second method I mentioned, where I'll produce two smaller alkenes. So I could choose to produce propene, let's say C3. Remember the alkenes, general formula is CnH2n. So I could produce propene, that's C3H6. I could produce maybe I could produce another alkene like C7, that's hexane. I could produce C7 H14. All right, so C7 H14. Then I can balance it with the hydrogen. All right, so this now balances it up. If you check it up, 3 plus 7, 10 hydrogens, 6 plus 14, 20 plus 2. So it depends on the question, like I said earlier. So these are the reactions of the alkanes. Quickly, we have the combustion reaction, we have the substitution reaction, and the major substitution reaction you should focus on is halogenation. All right, let me just scroll so that you can see what we're talking about. All right, so the major reaction is the halogenation, all right, which we talked about, where it's simply a group replaces another group. Two products are formed, all right, and it requires sunlight. The sunlight supplies activation energy, and any reaction that involves light, it's a photochemical reaction. All right, and we showed some examples where we were substituting the halogen into the alkane group. All right, and you can see that it's a we have a mono substitution, and then gradually we're moving to substitute. All right, and then the third reaction is cracking, okay, where we said we're trying to produce smaller useful products by breaking down a very large alkane. All right, so that is all the reactions that the alkanes will likely undergo. All right, and that's based on the syllabus. So we'll go straight to the alkenes now, because I want us to talk about the alkenes in this video before we now solve some past papers. All right, so I'll title this one Reactions of Alkenes. Reactions of Alkenes. All right, so reactions of alkenes. Now, the first reaction that alkenes undergo, which is similar or we say is the same as what alkanes undergo, is combustion. Combustion. All right. And remember what I said, there is the complete combustion and there is the incomplete combustion. So alkenes can undergo complete and they can also undergo incomplete. And they will give the same product just like the alkanes gave. So I'm just going to pick an alkane, pentene. For example, so C5H10 plus O2. All right, I'm going to pick another, I'm going to use the same alkene, C5H10 plus O2 again. So I'm going to do for complete and incomplete in both cases. All right, so complete combustion, CO2 plus water, as carbon dioxide plus water, like we earlier said. And then for incomplete, carbon monoxide plus water. All right, so the next step, balance. All right, so 5 carbons here, there should be 5 carbons here. All right, 10 hydrogens, so 5 here. So that 5 times 2 gives 10. And then let's look at oxygen. This is 10. 5 times 2 here, 10 plus 5. That's 15 oxygens. All right, so remember what I said, 15, 2. Yeah, so to look at you're going to be thinking of what number can you multiply to give by 2 to give 15. So that becomes difficult. So you just write the 15 divide by 2, and then you can remove the fraction there by multiplying by this, like we did in the other part of our case. So you could also try it out. All right, then we balance the next one. So 5 carbons here, so put a 5 carbon here. 10 hydrogens here, we put a 5 here. All right, and then oxygen is 5 plus 5, that's 10. So put a 5 here to balance that up, and that solves the problem of combustion reaction of alkenes. Okay, so we go to the second reaction quickly. This time we're going to go into reaction number 2, and reaction number 2 is called addition reaction. So this is simply the opposite of substitution. All right. Remember, in substitution, you are having two products being formed. But in addition reaction, one major feature of an addition reaction is that a single product is formed. And that's what makes it an addition reaction. Please note this point. What makes it an addition reaction is that a single product is formed. All right. So unlike the alkanes that undergo substitution, these ones they undergo addition, not substitution. Right? And remember, substitution produces two products. This time, addition reaction produces a single product. Now, an example of an addition reaction that alkenes undergo is, let's start with the first one, bromination. Okay, so bromination of alkenes. So we're going to pick an alkene, for example, such as 18. Remember what 18 looks like. So 18, this is 18. All right, 18. This is 18. So bromination introduce bromine, right? Now, in this case, of course, what happens is we have the bromine expanded now. So you see what is going on here. So what will happen in this case is this. I'm just going to use a different marker color, right? All right, so this is what happens here. This bromine goes to the carbon here, while the other bromine goes to this other carbon. So it's as simple as that. All right. And then the principle behind it is what we call the Markovnikov rule. But it's not in the syllabus, so we don't want to go into more details about that. But that is this works under the principle of what we call Markovnikov rule. All right. So look at what is going on here. The first bromine goes to the carbon on the left, the other bromine goes to the carbon on the right. And it has to be in between the two carbons where the double bond is. Okay, so majorly the bromine is attacking the double bond and is going to those carbons at both ends of the double bond. All right, so you have to be very careful. It's attack on the double bond and it's going to the two carbons exactly in between the double bonds. All right, so that's the case. So in this case now, we're going to have our product to be CH. So the first bromine goes there. All right, and then the double bond breaks to a single bond, and then we have C again, and then we have H, and then the bromine comes here. Now the bromine could occupy up, down, or whatever. It could be on the side. So irrespective, as long as it's attached to this carbon, it could be on top, it could be by the right, it could be down here. It doesn't matter. All right. So in this case now, let's name what we have. Let's name what we have. So we started with sorry, let me have to change this again. We started with 18. So we started with 18 with a double bond. So 18 all right, plus bromine. All right, so our product is now called, remember from our naming, 1, 2, 1, 2. So position is the same going forward and backward. So it's going to become the parent. What's the parent? The parent is the longest carbon atom is ethane here. So our parent is ethane. Parent is ethane. What are the substituents? So substituent is bromine. So bromo. So there are two bromos there. So bromo is the substituent. So since we know that, we can now name using the position. So lowest number, as usual, it takes whatever form, 1, comma, 2, because the first bromine is attached to position 1, the other bromine is attached to position 2, then you have your hyphen. And how many bromines are there? There are two of them, so dibromo. And then what's the name of the parent? Ethane. So this is what happens in the case of the bromination. You can see it's different from substitution. In addition, the two of them go into the structure, breaking the double bond, turn into a single bond, and they are attached to both ends of the carbon atoms where the double bond lies. Okay, so that is how it works for this. So I'm just going to do another example using a second member of this series. So I'm going to use propane. So you see what I'm talking about. So let's use propane in this case. So propane is C, double bond C, C. All right. And then we have H, 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 hydrogen, hydrogen, hydrogen. All right. So remember, propane is C3H6, and there are 6 hydrogens here, 3 carbons. So we introduce bromine again. This reaction, it doesn't require ultraviolet light like the substitution. So that's why I said you have to be careful. All right. And in this particular reaction, a single product is always formed. That's why it's an addition reaction. So just like we did for the previous example, this bromine now is going to where the double bond is attacking the carbon where the double bond, very close to the double bond. So this is going this way, all right? And the second bromine to go to where the carbon where the double bond is. So it's going this way. So it has no business with where the single bonds are. It's only attacking the carbons very close or directly opposite the double bond. That works. All right, so products now, C, H, H, and then the bromine there is going to be attached, okay? And then the double bond breaks to a single bond, all right? And then there is the H, and then there is the Br again, and then there is the C, H, 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 all right? Okay, sorry, let's do this. Bromine goes there. Okay, so we started with propene, with bromine, all right, and this time, what are we ending up with? So we start with the naming again. The longest carbon is 3, so our parent is propane. The parent is propane, all right, and then the substituents are still bromo. So our substituent is still bromo. So that's the substituent, all right. The parent is propane, substituent is bromo, and there are 2 of them. So let's number 1, 2, 3. Okay, so we've numbered forward, then we also have to number backward, and we have to pick the one with the lowest numbering. All right, and then we go 1, 2, 3. All right, so going forward is position 1, 2. Going backward is position 2, 3. So you know that position 1, 2 is lower than position 2, 3. All right, so that means we go for 1, 2 and not 2, 3. All right, so the name of the structure will now be 1, comma 2, how many bromines? Dibromo, and then we put the name of the parent, propane. So this is how the bromination reaction occurs. All right, that's good. So let's go to another reaction under addition. So there are several examples of addition reaction for the alkenes. One of them is what we just finished dealing with, which is the bromination. The second one we're going to look at as an addition reaction is what we call hydrogenation. Hydrogenation. All right. So hydrogenation means you are adding addition of hydrogen. addition of hydrogen. So basically, if you have an alkene, you add hydrogen to the alkene. The requirement is that you need a catalyst. So nickel is the catalyst. All right, and then the temperature is about 150 to 300 degrees Celsius. All right, so nickel is the catalyst, and this is the temperature condition. So you're going to produce an alkane, and that makes it an addition reaction because you're only producing a product, a single product. All right, so let's do just one example here because this is straightforward. It's just the same principle like what we did for the bromination. Same principle. So H2 this time. H2 simply, that nickel is the catalyst and the temperature is also there. So 150 to 300 degrees Celsius. So HH, going in again. So this H goes to this carbon, the other H goes to the second carbon. All right, so that's how it works. And then your product will be C, first carbon CH, H, H, all right, and then double bond will break again to single bond, and then H, H, H. So basically, what we see here is that we move from ethene to ethane. So whenever hydrogenation is occurring, you're moving from an alkene to an alkane. Simple. So if your starting alkene is propane, that means your alkane should be propane. If your starting alkene is butene, that means your alkane is going to be butane. So that's just how easy it is for the hydrogenation. Same principle as what we refer. Addition, a single product, and then you show how the double bond is broken to a single bond. All right, so we go to the next reaction, which is, we'll call this one hydration. Hydration. All right, so in hydration, it's different from hydrogenation because in this case, what you are simply doing is you're adding steam. So addition of steam. That is what hydration means, addition of steam. All right, so in this case, alkene plus steam, all right, steam. Conditions of the reaction is you need an acid catalyst. So the acid catalyst is called phosphoric 5 acid. Phosphoric 5 acid. You need to know this condition. Phosphoric 5 acid is the acid catalyst that is needed, and that's simply saying H3PO4. That's phosphoric 5 acid. All right, you need a temperature of 300 degrees Celsius, and you need a pressure of 6,000 kPa. So these conditions are very important. You have to know them. All right, the acid catalyst is phosphoric 5 acid. You need a temperature of 300 degrees Celsius, and you need a pressure of 6,000 kPa. And by the time you do that, you're going to have an alcohol as your product. So it's an addition reaction. As is usual, a single product is formed. All right, so let's see an example in this case. So let's pick ethene as usual. Ethene. So ethene, H, 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 H. All right, plus steam. Steam here is like H2O. So H2O. All right, so the conditions should be there. So when we are moving from ethene, you should know that you're going to produce an alcohol. All right, so H2O simply means, break it down, like expand it, we have HOH. All right, so what this simply means is that, as usual, one of these goes here, the other part goes here. So that's just the principle, the same principle. So products now will be C, H, H, H. All right, and then we're going to have C, H. Just have to erase this. So you're going to have C, H. All right, and then the OH now goes in, so we could have it as OH, or you could expand it to have the O, show the display, since we are doing display formula. So you could simply show the OH there. All right. So what we've done is we've moved from ethene to ethanol. Okay, and that is how it works for hydration. All right, ethene to ethanol. So let's see another member. Let's see another member. Let's see propane. Let's see propane. So propane C3H6 as usual. So C double bond CC. All right. So H H H H H H. So C3H6 plus team H2O. All right. So remember what we did? HOH again. Now, Markovnikov rule is telling us that one of the this goes right here, right, and then this other one goes here. But there's a rule that also says that the hydrogen goes to the carbon with more hydrogens. All right, the hydrogen goes to the carbon that has more hydrogens. All right, but we're going to come to that. Like I said, I don't want us to talk about it in details here. All right, so the product is going to be let's see what we have now. One H H H. All right, and then CH. So the AHOH now, okay, because it has to be the attack needs to be where the carbons very much opposite to the double bond. All right, so H. All right, so this is what happens in propane. So now we have to name this. So because the OH group, which is the alcohol group, is on the second carbon. You know, this is 1, this is 2, this is 3. So this is called propan 2 all. All right, so this is a major product of this reaction. So this is now the major. All right, so that means if we follow what Markovnikov is saying, there is also what we call a minor product. All right, if this is the major product, the minor product is going to be an isomer of this. So the isomer of propan-2-ol will now be like this. All right, so let's draw the minor now. So C, C, C. So for us to draw the minor, all we need to do is to move the functional group, that's the OH, to another position apart from position 2. So we can simply move it to position 1. All right, so we're moving to the first carbon here. All right, so remember this is position 1. There's nothing like position 3 here because you are looking at the list number. Okay, you are giving preference to the list number. All right, so this is now a structural isomer of propan-2-ol. So we call this propan-1-ol. Okay, because this is 1, 2, 3, 1, 2, 3, 3, 1. But we give preference to the lowest number, so 1. So this is propan-1-ol. So there are major products and there are minor products. That was what Markovnikov was trying to explain when alkenes undergo alkenes and alkynes majorly. But our focus is on alkenes. All right, so there are two products. There is the major product means the one with greater yield, and then there is the one with the lesser yield, which is the minor product. So propan-2-ol is a major, and then the minor is propan-1-ol. So you can also do for butene. Butene will also have two products, major and minor. So you have butan-2-ol and butan-1-ol. So that's how it works. All right, so this is what happens for hydration. I believe it's clear enough for us to understand. We could watch this video over and over again to see what I'm trying to do there. All right, so let's talk about the last reaction, last type of addition reaction of the alkenes. You know, we've done bromination, we've done hydrogenation, we've done hydration, and then the fourth one is polymerization. All right, I'm not going to talk too much about the polymerization reaction because I'm going to do a video on polymers, and that's where I'm going to give a detailed explanation of this. But polymerization simply means if you have an alkene, for example, polymerize an alkene, let's say we are polymerizing ethene. Polymerize means add several small units of these alkenes. All right, so these small alkenes that you are adding several units of are called monomers. So polymerization means add several monomers of an alkene to produce a polymer. So polymerization reaction applies majorly to the alkenes, and that is why we are considering alkenes in this case. So when you polymerize, so this N here represents how many units of the alkenes, which is the monomer that I want to merge. So if I'm merging about 1,000,000 units or 1,000,000,000 units of alkene, I'm going to produce a polymer of an alkene. All right. So when I do this, I will need a high temperature, of course, high temperature and pressure, high temperature, high pressure. All right. So when I do this, I'm going to have a polymer. So how do I represent my polymer? It's very important. So my polymer is going to look like this. The double bond is going to break to a single bond. Then I'm going to have my hydrogen up here, hydrogen up here, hydrogen. Okay. I'm going to have a bracket. All right. And I'm going to have the bonds. All right. So this bond needs to extend outside the bracket. If we are using this bracket representation, it has to extend outside the bracket a bit, all right? And then I'll put the N, okay, depending on how many monomer units I'm using. Okay, so this is how to represent a polymer. So this is ethene now, and then this is now called polyethene. All right. Or another way I could draw this is to just draw carbon, carbon, all right, H, 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 then I'll just put the continuation bonds. This is another example. This is another way of drawing a polymer. So either way works out, okay, for the polymer. So yeah, you draw it this way or you draw it this way. So the major thing we're drawing it the second way is that you have to use the continuation bond. And while you're using the brackets, for the first case, you have to make sure that your continuation bond extends a bit outside the brackets. So these are all of the reactions of the alkenes and alkanes. So in our next video, which I want you to anticipate, we'll now solve past papers, applying. You can solve those past papers and many other questions like that. So thank you, and continue to spread this to your friends.